Hey, I just wanted to make a video showing you guys kind of what I'm talking about when on the next slide. So on the next slide, you're going to be drawing a hanger diagram, and then you're going to be writing an equation to match that diagram. Okay, it's exactly what we've been working on, but except instead of you kind of figuring it out from what you're given, you're going to make the diagram yourself and the equation. All right. So what I would do here is I'm going to think about a diagram, and I'm just going to make one. Okay. So here's the thing: don't make my diagram. Make your own. Okay. I'm going to make a simple one though. So I'm going to start, and I'm going to do, let's see, I'm going to make a square. So I'll make one square. I'll make another square. So then I'm going to have two squares, and then on the left side, and then I'm going to have maybe three triangles. I think that's what I want to put on my left side. So I have two squares and I have three triangles. Okay. And then on the right side, I think I'm going to do two circles. I think I'm going to make two circles. So I got one circle, two circles. And then I think I'm going to have one square. And then I think I'm going to have one triangle. One triangle. Okay. And so I've made this hanger diagram. And so let me see if I want to write my equation now for it. So here's my hanger diagram. So I've got that. Check that off. Right. Done. And then if I want to make an equation from this, okay, so now I need to put in my variables as they're represented. And I'm just going to keep them the same. I'm going to say that my x's, and I'll write it so you guys kind of see. So my x is squares, right? My y is triangles, and my and z, x, y, z, and z is my circle. So or are my circles. So so now here's the thing: you don't have to do it this way. If you wanted x to be triangles and y, or if you want a to be squares, b to be triangles, and c to be circles, if you want s to be squares, if you want y's or t's to be triangles and c's to be squares, if that makes more sense to you, you could totally do it that way. Okay, you don't have to use these variables. This is just what I'm using. This is just what the book used, but this is not what you have to use. You could totally say STC. That's totally fine. Okay, so let's look. So I'm using XYZ. All right, so I'm going to make an equation. So I'm going to actually label these so I know what I'm doing. So this is my diagram. This is my diagram. Or you could just write this is your hanger. Okay, and then this over here is going to be my equation. My equation. Okay. And so my equation, I'm going to look at my left side over here, and I'm going to see that I have two squares, and I know x represents my squares, so I'm going to say 2x, and then I have three more triangles, so plus, and y are my triangles, so I have three y's. And then I know on my right side, I have two circles. So I have two circles, so I have two z's, because those are circles, plus, what do I have? Plus one square, so plus x. I only have one square, so just one x. And then I have one triangle, so plus one y, so just a y, because that's the triangles. And what am I missing in the middle? That has to be in every equation, my equal sign. Okay? And you don't need to simplify this or anything like that. I just want you to make a diagram and then create an equation that matches that diagram. So I have two squares, 2x, three triangles, 3y on my left side, two circles on the right, one square and one triangle, 2z, 1x, 1y. Okay? All right. You can make yours way more complex if you want. You can make it a little simpler if you like, however you want to do it. Okay, you're just making a diagram and an equation on the next slide. All right, thanks.